Hello, welcome to PhyzQuest. So this is the solution video for CSIR NET December 2019 Part B, question number 12. So the question is, an ideal Carnot engine extracts 100 joule from a heat source and dumps 40 joule to a heat sink at 300 Kelvin. We need to find out the temperature of the heat source. 4 options are given and we need to find out which is the correct option. So let's get started. Now this question comes from the section Heat and Thermodynamics, and the concept involved here is Carnot engine. Now when we talk about any type of a heat engine, heat engine is a device which converts heat supply into some mechanical work. Suppose you have a hot body called source which is at temperature T1 and a cold body called sink which is at temperature T2. And there is a working substance in between the two bodies which takes heat from the hot body source and converts some amount of heat into mechanical work and rejects remaining amount of the heat to the sink. So this actually constitutes a basic heat engine. Now the amount of heat which is converted to mechanical work is the efficiency of the heat engine. So suppose if the working substance takes Q1 amount of heat from the source and rejects Q2 amount of heat to the sink, that means the difference Q1 minus Q2 is the amount of heat which is converted to work. So by definition of efficiency, efficiency is the ratio of the work converted to the heat supplied, which is eta is equal to W by Q1 here. Now W is actually Q1 minus Q2. So that means it's Q1 minus Q2 by Q1, which is actually equal to eta is equal to 1 minus Q2 by Q1. So this equation is valid for all type of heat engine. Now when we talk about Carnot engine is a special case which is an ideal type of engine actually. Why ideal? Because in any general type of heat engine, when heat is taken out or given back, there should be a change in temperature in source or sink. But in Carnot engine, this does not happen. The temperature of both source and sink will remain maintained at that temperature. So if Carnot engine, so what happens is in Carnot engine there is a relationship is established between the temperature of source and the sink. So for this same given set, in case of Carnot engine, the efficiency is given as eta is equal to 1 minus T2 by T1. So this equation is valid for Carnot engine. Now here the first equation, this one, is valid for any type of heat engine including Carnot engine. This is valid only in case of ideal Carnot engine. So by comparing, we are here in this question we are considering an ideal Carnot engine. So both the relationship are valid here. So by comparing both the relationship, we get Q2 by Q1 is equal to T2 by T1. Now in the given question, the Carnot engine extracts 100 joule from the source and rejects 40 joule to the sink at temperature 300 Kelvin, and we need to find out the temperature of the source. So that means we have Q1 is equal to 100 joule, Q2 is equal to 40 joule, T2 is equal to 300 Kelvin, and T1 is what we need to find out. So these are the data we have. So if we put the given data in this equation, we can easily calculate the value of T1. So putting the value in this equation, we have 40 joule by 100 joule is equal to 300 Kelvin by T1. So from this, T1 will be equal to 300 into 100 divided by 40, which comes out as 750 Kelvin. So this is the temperature of the source. Now let's check the option. So if you look at the option, you can see that Option C is matching with the result. So correct answer for this question is option C.